I'm at work and it says I have full. Oh, let's start recording. Okay.
It says
I have full bars, but okay.
Okay, perfect. Yeah, it says recording. So, okay, good.
Let's go, guys.
Hi, how are you?
Hello. I think we're just missing my partner, Kristen. Do you guys mind if we go first because she's at work too and she's taking her break right at 2?
That's
Is
okay.
that all right? Okay. Cool. Are I missing anyone else? I don't think so, right?
No.
I think we're missing 3 people total. It's supposed to be 8.
Oh, okay.
Yeah.
Cool. Hello?
Yeah, 8 total.
There should be a breakout room. Can you join breakout rooms? Okay, you're good. One. So we're missing one more person. I don't know if we should just.
Yep.
Do we know who the missing person was? Because I think there was one group in ours that was just a single person.
Yeah, that's me.
I could be wrong.
Yeah, let me see the list.
We're supposed to be 4
It's
groups.
Because I remember it was an odd number.
Yeah.
Yeah.
London is the one by himself. Paula.
Uh-huh.
So who we're missing is from our group, actually. It's Miguel Ortiz. I think he's trying to figure out how to, yeah, he says connecting right now, so.
Okay, cool.
Yeah.
Kristen, do you have our PowerPoint pulled up? Okay. Cool, we got everyone. If they're not co-hosts, can they share their screen?
I think you can give the option when you click on share screen, it's going to tell you to do it.
Can you guys see my screen?
Yes.
Okay, cool. Hold on. All right, should we start?
Yes.
Okay. Okay, I'm Kristen.
So I'm Mariana. We're doing technology and autonomous vehicles.
Oh, sorry.
That's okay. So autonomous cars have been in development for a long time. While self-driving cars started coming around in a series of projects in the 80s, there has been experiments of this nature for nearly 100 years. We know autonomous cars are equipped with a mix of hardware and software, and so far technologies have been able to provide a number of innovative features in vehicles such as assisted parking, self-braking systems and assisting road maintenance. However, there's still ways to go before they can all reach level 5 autonomy, which is where there's full automation without human intervention needed. So there's still some problems with autonomous cars. Not everyone is on board with them because some people think they're like not as safe and they want to be in control, and other people are totally on board for it. So while companies have progressed since the 80s, there's still a ways to go due to cost and regulations also. There's still research that needs to be done before a vehicle can be in charge of everything. And being that they are computers that are in the cars, just like our computers can get hacked, so can those, and then that can cause problems. And then companies are also incorporating biometric systems and for both security and convenience. However, there are concerns that like some people don't want all their personal data being in a car or like being given out. And relating to privacy, there's only a few states that have passed laws regulating the collection and security of biometric data. And lastly, it could be a couple years until companies reach level 5 autonomy, or it could be a very long time and a lot of money invested for them not to fully work.
All right, so obviously the significance is going to be that it's a lot safer in ways, even though a lot of people don't think so. It definitely is. Hopefully one day all the cars can talk to each other. That would be great. There would be no slow drivers on the road. We would love that. It's a big step in technology because it is a combination of both hardware and software, which, you know, has taken a long time to perfect. More efficient, more economic, obviously, because eventually we hope to, you know, not have to use gas all the time, maybe solar powered, all that good stuff, if we can figure that out. Saving time, safer. I don't know if you guys have noticed, but there's a lot of self-driving cars out there that act as buses. I actually saw one for the first time last week, and it was pretty cool. There's no one driving it. It's literally just a car that goes on its same trip every day, picks up people. So, you know, that would be great for overnight buses rather than, you know, stopping routes because they don't have people for overnight. Let's see, did I hit everything? Okay, so our objectives for this paper is going to be to further understand the sensor technology of autonomous cars. That's the main technology used in the cars being able to drive itself. We also want to further understand the advanced driver assistance systems in vehicles, which is going to be basically your blind spot warnings in cars that don't self-drive, but also the cars that will self-drive. And then just the overall pros and cons of having self-driving cars, which is basically, you know, some things that we just touched up on, you know, safety, overnight driving, kind of stuff like that. Okay, so this is going to be basically an overview of what we hope to hit on in our paper. Go in depth on the sensor technology, which again is how the car communicates, and then going in depth about the safety features, and then just a background on that because not a lot of people know about that. Some people still have a lot of older cars. I have a new car, so I had to learn about all that new stuff that had, you know, like the pre-collision warnings is something that I love in my car. That's something I needed. I'm sorry, everybody's really loud around me. I hope you guys can still hear me. And then again, the pros and cons. Pros of sensor and safety features, basically just why it's beneficial, and then the cons, you know, why it's a hassle, why people hate it, you know, technology is going to take over the world, all that good stuff.
So our overall, we hope to learn more about cars ourselves while being able to teach everyone else about our findings. we hope to dig deeper into the technology that has already been implemented into these vehicles. Like the Ford F-150 just came out, and I know they probably have, like, it's a fancy new car that a lot of people like, but I'm sure there's still faults in it. And so we hope to also research the hardware and software that these companies are looking forward to discovering in the coming years to make all these cars even better. And one day I'm sure we'll all be driving these fancy cars that just drive itself, and then you can just take naps.
Oh,
And then so for our schedule this week, we just obviously prepared our proposal, and next week we'll start researching more in depth, and then we'll work on our rough draft and then our presentation, do a little run through and get ready for when we have to do it. And then the last week presentation week. Our focus areas are technology and biometric systems. That might change a little bit. I don't know. We're kind of still looking into that, but as of right now, that's kind of where we're going.
still in the research phase.
And then these are our references for some information. Any questions?
I actually have a question. It's a simple one, but to me it's important. Is what was your main motivation to choose this topic in particular?
For me personally, I've always loved Teslas. Like, I test drove one, not this Christmas that just passed, but the previous one, and it was beautiful. Like, I want one so bad. But obviously, like, I still want to wait. Like, I can't afford one right now, but I also do want to wait till they develop technology a little bit more. But a Tesla and Escalade are the dream cars.
Oh, yeah. Yeah, it feels sometimes that the technology.
Yeah, I
can
have
be a
to
little-
agree. That's probably the same thing for me too.
Okay, good.
Oh, sorry, you guys.
Oh, no, that it feels sometimes that there's
What?
still a lot of things to do in this field, but yeah, it's definitely a very exciting topic.
Thank
It's
you.
always growing, and it's weird how sensors work. So it's going to be really cool to be able to go in depth and just be like, okay, there's such thing as a sensor, and for some reason it can like detect you over here. So
Yeah.
that's going to be very interesting, and hopefully you guys enjoy when we actually present it.
Yeah, absolutely. Are there any other questions?
I have a question.
Yeah, Kirsten has one.
In your
I think.
preliminary research so far, have you been able to see what maybe the biggest problem with autonomous cars right now is?
For me, I think like the biggest problem is not everybody's on board with, because I mean, if you think about it, when you're in the car, you're in full control of where the vehicle's going, when you're braking, when you're doing everything. So I think once we do transition in, I don't know, could be 10 years, could be 100, to fully autonomous cars, those people aren't going to, I mean, if it's right now, obviously we're used to driving our own cars, so it would be really weird for us to go, and some people might not feel safe because, yeah, it can brake for you, but how close do you like getting to the car in front of you, or how far back, or, but in 100 years, whenever new people come into this generation, that might be the only cars that are around. So they're gonna be like, oh yeah, I don't know any regular cars.
Another problem too that I found is insurance wise, because it's like, okay, you got a self-driving car. Do you blame the person that's sitting in the car? Do you blame the person that hit them? Do you blame the technology? Who's at fault? So a lot of insurances don't want self-driving cars. However, technology-wise, and that's another thing that's probably going to be in the pros and cons thing that we'll go more in depth into, is like, is it going to happen, or are the insurances not going to let that happen? So not only technology, but also like human thought processes, I guess, So.
I have a question.
Oh.
Are you guys interested any at all in, I guess, since you guys are focusing on a security and safety perspective, are you guys interested at all in, I guess, some of the algorithms used for like training some of the self-driving vehicles, especially with respect to, I guess, making decisions about where damage might be minimized, right? Do you prioritize the driver versus, other drivers on the outside and stuff like that?
Definitely. That goes into the what I said before. I think it was like the assistive driving thing. So there's a lot of safety features that many cars have that aren't self-driving now. And even still, the way I used to have a Hyundai, so the way they built the cars was kind of like an accordion effect. So if for some reason you did hit the front of the car, it would go, the stuff would go down rather than hit the driver. So in a way, the pre-collision warnings can help a lot. My car right now is set to 3 car lengths ahead, and then it'll ding me. So especially for self-driving cars, that's going to be very, very, very important for the sensors to be, working tip-top notch, so that if something does go wrong, it's going to alert the driver or stop the vehicle or whatever. So safety features, how the car is built, all that stuff is going to definitely have to be in our paper, because it's has to do a lot with like the sensors and then just safety features in general. I can't really hear that well. I think that's what you asked. Correct me if I'm wrong. There's a lot going on here.
Oh yeah.
No, I did read. Oh, I was reading about like some people. So like the goal is obviously, yes, to make it safe for everybody and like minimize congestion, but that's going to take a while. But yes, in our paper, we hope to try to get as much information as we can to share with you guys about all those safety features that Kristen mentioned. And like she has them in her car, and my car is 2 years older than hers, and it doesn't have, like, mine has like the backup camera, but it doesn't have the collision crash. Like cars each every year they're starting to add like another feature that kind of comes in like the basic package, because now that there's more technology, even like blind spot monitors, it's not like a big thing, but a lot of cars nowadays have them. So like slowly they start implementing features that you don't have to have the top of the line car to get everything, like the package deal. Like in my car, I just have those little mirrors that you buy on Amazon that act as a blind spot monitor. But my car's a 2017. So like Kristen might already have it in there. Like my grandparents have a 2020 Sorento, and it has it already, and it was the basic car.
Yeah.
Well, I actually, since you were talking about sensors, I kind of wanted to, I'm kind of interested in the sensors part, but the cost part of it, because obviously having one car with so many sensors, right? It gets very expensive. Have you considered in your paper probably touch base a little bit in how much is, the average sensor price right now based on obviously the types of sensors that are used? Because I know that there are sensors there that are extremely expensive, and that's why the technology has taken also a lot of time to, to be available to everybody, because it will be a very expensive car. But I don't know at what point those sensors are more available at this moment. So I don't know if you have considered something in that area.
Yeah, I had read that like costs and regulations is a lot of the problem of being able to reach level 5 autonomy, because it's to build a car that's going to, and especially if they want everybody to eventually have a car like this, it's going to be expensive. So I didn't really get to do a lot of research on sensors and costs, but we do plan on hoping to at least touch a little bit on our literature review.
Mm-hmm.
Any
more questions? I think we might be over our limit.
Okay. Okay. Who wants to go next?
I guess our group can go next.
Okay.
That's good. Can everyone hear me okay?
Yes.
Okay.
Yes.
My name is Kirsten Zima, and with my partner Nathan Moulton, and our project is based on the wireless-based IoT mesh networks, specifically the network of Z-Wave that can be found in smart homes.
All right. So with respect to IoT networks, with the advent of wireless communications and embedded devices that can utilize them, IoT has been on the rise. And when you hear IoT, you often think about smart homes, you think about devices and infrastructure. But in our presentation, we're going to be honing in our focus a bit more on a particular, on communication protocols, in particular Z-Wave. So Z-Wave is an alternative wireless communication protocol, much like Bluetooth or Wi-Fi, but it's distinct in a variety of ways. And even though it is an alternative to these platforms in a lot of different respects, it still has a broad range of support. With you being able to get smart security networks from the likes of companies like Ring and Dome, to sensory devices from companies like Ecolink or Water Leak, and freeze detectors from companies like Z-Link.
And a lot of the things with Z-Wave is it is lesser known than many bigger networks, like we hear all the time, like Wi-Fi and Bluetooth, and that's why it was very much interesting to look into, since not many people would know about it in a basic conversation. A lot of problems that come with the IoT mesh network is connectivity, because people want their devices to be talking to each other, information to be relayed over a desired area, whether it's a home or open space. They want their devices to be talking to each other. That also comes in with a lack of range, and the range going over the desired area, as well as interoperability, which there's a lot of different companies that they have the same type of devices, or they have devices that could work with each other, but because of their different setups, they can't work with each other. Like many devices for Zigbee or Wi-Fi, the devices automatically can't work with each other because of the different companies it come from, and that gets into the Z-Wave Alliance. Also, a demand for the low-powered battery-operated devices, since people don't want wires all over their house, and security concerns, especially when it comes to security systems, because people want to protect their families and their belongings.
So as previously stated, IoT networks are rapidly expanding. When you look at all of the market projections for years to come, you see that home automation is definitely one of the sectors that's really ballooning. But we're also seeing IoT networks being used in a variety of other contexts, which we'll go into later. Of course, this increased demand for IoT devices and their networks means that we're going to be looking at a future where more and more critical functions are dependent upon IoT devices, and that really increases the emphasis on security and operation on a day-to-day basis, making sure that communications between devices and control hubs are reliable and fault tolerant, but also making sure that our networks are resistive to being exploited by bad actors.
We are hoping to show that there are other alternatives in IoT devices than what we just see in Wi-Fi, Bluetooth, or Zigbee. And something that wasn't mentioned previously was all three of those operate around the same frequency at 2.4 gigahertz, while Z-Wave operates at a way lower frequency of 800 to 900 megahertz in a completely different spectrum from the other three, which is quite interesting. And with that comes different ways of it working with both pros and cons, and to understand the pros and cons and how those operating at different frequencies affects the networks in question. We plan to do an overview of different home automation IoT networks like Wi-Fi, Zigbee, Bluetooth, and Z-Wave, and compare them and see how Z-Wave operates differently because of its frequency and the Z-Wave Alliance for interoperability, and then look really in depth to how its protocol stack and architecture and how it's set up and how it varies from the other IoT networks that can be implemented, and then the incorporation of the networks in many applications, mostly in home automation, but also dabbling into other fields that it can reach and is going into.
Okay, so for our preliminary literature review, and moving forward, we're going to be focusing on Z-Wave architecture, talking about some of the network properties of this protocol and how that relates to other competitor protocols like Wi-Fi, Zigbee, and Bluetooth, as well as touching on how that architecture leaves some security concerns and how those can be addressed. We're also going to be talking about network implementation and use cases. As mentioned plenty of times, you're going to see a lot of home automation brought up when we're talking about IoT, but there are a lot of use cases coming up for Z-Wave in particular in a variety of other fields in healthcare with respect to glucose sensors and smart patient monitoring systems, as well as by a variety of companies attempting to use these protocols for traffic monitoring as well. We're going to be talking about device support, about how even though Z-Wave is an alternative to a lot of these arguably more popular protocols, that there is a variety of devices and over 700 companies offering support for these devices, all certified by the Z-Wave Alliance, which is committed to making sure that these devices are up to par. And we're going to be talking about some of the limitations inherent to Z-Wave with respect to support for certain devices.
This is the schedule that we're going to try to stick to. We already started doing research, especially for preliminary research, since we had to do our project proposal. And we will continue doing that research because I think the gathering of research and the gathering of information to compile a paper and provide the best source of information or the best information possible is extremely important. And then we'll have a week to work on our paper about and our presentation until the presentations week. The focus areas that we're going to be focusing on, I will be primarily focusing on the Z-Wave architecture and platform limitations, and going forth comparing Z-Wave to very well-known other IoT networks like Wi-Fi and Bluetooth, and doing compare and contrasting to how each of them work, and that will help explain how Z-Wave works as well.
And I'll be focusing on Z-Wave implementation, different applications, and, as well as current and potential use cases for the networks, and talking a little bit about the limitations in terms of device support So for our concluding remarks, again, the purpose of this literature review of ours is to give you all an overview of Z-Wave, this alternative, and kind of try to paint a picture of how Z-Wave fits into a holistic view of IoT networks.
Especially since Z-Wave is lesser known, and whenever we think of wireless, we think of Wi-Fi and Bluetooth, but there are so many other protocols and networks out there that are being created every day and are being utilized in different devices, and we want to give you information on one of those wireless IoT networks, Z-Wave. Here's all our references to get information for presenting. Any questions?
Hi, I have a question before I leave because I got to get back to work. Sorry if you already said it. I had a couple people asking me questions. Are you guys going to be going in depth about how, different devices talk to each other? And because like you said at the very end, like a lot of people think about like Wi-Fi and Bluetooth. That's actually what I was thinking the whole time you were talking about Z-Waves, was like, oh, is this kind of like Bluetooth? And then at the end you were just like, yeah, a lot of people think about Bluetooth. So I, maybe you said it. I'm sorry if I'm making you say it again, but something I would like to know more about is how they actually communicate with each other if it isn't Bluetooth. You know what I mean?
Mm-hmm. So we will be going into that. This is primarily a mesh network, but it comes in different topologies. And depending on the topology means that it will talk to each other differently. There is Z-Wave, which is mostly a mesh network, but then the same company also recently created another one called Z-Wave Long Range, which has a range of, they say, up to or like miles long. And that one is a star topology. So the architecture and the networks talk to each other differently depending on the type of network, and we will be going over those.
That's awesome. I'm really excited to see your guys' presentation and learn about that topography or whatever you just said.
Thank you.
I also have a question. I might be living under a rock, but what is Zigbee? Is that kind of like a different kind of Wi-Fi, or?
Right. So it's a communication wireless communication protocol, somewhat like Wi-Fi. In our presentation, we're going to be talking about what its core features are, in contrast with other options like Wi-Fi and Bluetooth. But just very quickly, it's as Kirsten said, it's a mesh node. It's a mesh node network, which means that there is going to be a central, controlling hub, but devices in the setup will be able to speak with each other without having to communicate to a central hub. And one of the other features that Kirsten also mentioned earlier was that it communicates. The communications are at a frequency that's lower than a lot of other options like Wi-Fi and Bluetooth, which are around 2.4 gigahertz. So in the United States, Zigbee communicates around like 908 megahertz, if I believe. And
there's
because they're two, yeah.
Yeah. One of them's a 908.4 megahertz, and I think the other one is a 915. And Zigbee also has, Zigbee is like Z-Wave, where it's like a wireless, hang on to what Nathan said, is a wireless communication system. One big difference between Zigbee and Z-Wave is the Z-Wave has a Z-Wave Alliance, which restricts what the Z-Wave products will be, and that's why products can talk to each other. Zigbee doesn't have that. So because of that, you'll have two Zigbee operated products from different companies, but they don't work with each other.
Cool. You guys know a lot about this. It's pretty interesting.
I've got a question. Does this technology can be used in vehicles or not?
I haven't seen yeah, I haven't seen anything like that yet.
Okay,
I
thank
have to
you.
research further to see that kind of application.
Okay, sounds very interesting.
In the preliminary research, we haven't found anything like that yet. Mostly probably because it does require a central node to transmit data to someone's phone. So that's definitely something we'll look into and hopefully
For sure.
bring up in our presentation.
I have a question too. Are there any products right now that are probably popular there that we haven't realized that are using this type of technology? Because this is a new topic to me too. So, I mean, it would be good to have some type of reference and say, oh, you know what? This is that new technology that I hear my classmates talking about. I mean, I don't know if you know any of those at the moment.
The security system Amazon Ring. That one specifically, I was helping put one up and I turned it around and said powered by Z-Wave and I went, oh.
Oh, wow. Thank you.
And companies like General Electric have lighting solutions that use Z-Wave for communications as well.
Okay, good, good. Thanks.
Yeah, that too. Any other questions?
Thank you, guys.
Yeah, thank you so much. That concludes our presentation.
Thank you.
Thank you for all
Who
the
wants
great
to go
questions.
next?
I can go next.
Okay.
Okay, so my topic is a little bit different in the sense that it's a mix between IoT technology and the world of business from a business perspective. So my topic is IoT in the hotel industry. I'm the only member of the team. My name is Paola Londono. And the purpose of this literary review is to learn more about the hotel industry and what they're doing with the IoT technology, what are the opportunities and the challenges that they have. And I want to understand what happened in the industry in order to fully optimize all the aspects of this business. So the question is, why am I focusing on in the hotel industry? And pretty much Florida has something that will never go away, that is tourists. So that's why I'm centering on this in this topic, because obviously they bring a lot of business to the state. So for motivation, I have this graph here. The numbers don't lie. We can see in 2018, Florida accommodations and food industry provided or contributed almost $47 billion to the state GDP, which is the gross domestic product. I have attached this graph to the right, showing also that the same industry in 2020, during pandemic, they were able to contribute $42.11 billion to the state also. So the money is there. They still generate a lot of money, even if we were under the problem, with the COVID issue. So now let's look at this other slide, the average number of hotel employee per year in Florida. We can see numbers here from 2011 all the way to 2021. The source is from the US Bureau of Labor Statistics. We can see that every year the number went up, up, up. For 2019, we had 1.26 million employees average per year. When 2020 came, they went down. But if you see the numbers for 2021, they're almost the same. In the middle of the year, they're almost the same as the total numbers for 2020. So obviously the number of employees will continue increasing too. Now let's take a look at these other two graphs. The one on the left that shows the number of Florida visitors per year. We can see from 2016 all the way to 2020. This is in, as we can see, I mean, they were increasing all the time. Look at the number of visitors in Florida, 131.422. And then if you look at the annual growth, it's a percentage for every year. We have here 6.1%, 4.8%, 2.9%. But if you see the total of the graph for the past 10 years, pretty much there was an increase of 50%. Now COVID came and it went down for almost 40%. But that's obviously one of those cases that are not always happening. So we can see that the motivation to grow this industry, the hotel industry, is there. Okay, so the hotel industry has been actually using this IoT technology for a while now. Many hotels have adopted quickly, not only to improve customer satisfaction, but also to optimize their operations. The technology consulting firm PwC did this survey, and they asked many hotels in the industry to see if they were going to be doing some type of improvement in the area of IoT. And 70% of the businesses actually have done something related to IoT in the hotel industry compared to, for example, to the industrial sector. Even though they work with robots and with sensors and all that stuff, they only reported 48% of the firms are actually working more towards the implementation of IoT devices. So obviously in the hotel industry, 70% is a very big number to keep in mind. So some of the current works that are there for hotels and the use of IoT, they pretty much have the focus in customer service, sales, profit, facilities, operations, and security. So those are the areas where they're trying to use IoT technology. So one of the most popular ways to use IoT is by using data devices like smartphones. With this, they're trying to the customer experience part. For example, just really fast for housekeeping, they know when a room is vacated because the vacancy sensors will tell them that there is no one in the room. So now they can go and clean the room without having to be there knocking on the door and asking the guests if they're there or not. Another way to use IoT, for example, they use these cards for the luggage with GPS sensors. So the guest knows exactly where their luggage is at any point in time. So some of the current works also include the part of opportunities and challenges. There are definitely many opportunities, not only in the aspect of customer service and optimizing operations and increasing profit that this field is going to bring to the hotel industry, but also the generation of data that obviously, I mean, with big data techniques, that's a big thing that the hotel industry is working around at the moment. So that's a great opportunity because with this, obviously, they're going to be able to learn more about customer behavior and how to deal with other situations to optimize their operations. And also with any type of opportunity, there are also challenges, obviously, not just the generation of data. Obviously, there has to be a way to manage it, and it's not easy, and it requires employees, it requires technology, it requires money, it requires time. So scalability is one of those issues that they're finding that is obviously complicated. This obviously, like I just mentioned, the amount of data that they have to work with, that they have to process. Those are all a lot of challenges that they're experimenting at the time. The software complexity, what type of software is going to be able to deal with all this new data and process it so they can analyze data. So there are a lot of challenges there. So I'll be covering that during my literary review. And with all this, with what I'm trying to do, the outcome is to identify the changes that the industry needs to go through in order to implement the IoT technology in their daily operations, so they can definitely take advantage of all the benefits that the technology can provide to this industry. That, like I mentioned before, is a very important industry in the state of Florida, especially because of all the money and the tourists that we get every year. With this, well, obviously they can achieve optimization of all the processes, and they can also get higher profits. This is my schedule. Since it's just me, it's going to be my pace. The next 2 weeks, I'll be finding probably more research and taking notes. And then the week of July 16, I'll be writing my survey. Then the week of July 25th, I'll be creating my presentation slides, and then just get ready for my presentation. These are some of the references that I have. And do you guys have any questions?
I have one. This was super interesting. It's kind of like the cars, like how you're developing technology and how hotels develop more technology. I was wondering, how did you, like, what made you pick this topic? Did it just come to you, or did you have to actually sit there?
No, well, I have a background in business management and finance. In business in general, I have my own businesses and everything. So I'm always kind of like putting my mind there in that area. So I thought that just looking at how IoT can actually affect the daily operations of a business, it's very interesting. Now, why tourism? Just like I said, I mean, there are so many areas. I've worked in many different industries during the years, but I think since we are in Florida and I see tourists everywhere, that was a good opportunity for me to see, hey, you know, this is what they're doing on a daily basis just to make everybody want to go on vacation and go to this hotel and, you know, be a repeat customer, because that's what they're looking for. They're looking for those clients that want to go back all the time, and they're going to be loyal to them, and then they're going to go and do the Google review and their likes and their Facebook accounts and all that stuff. So that I'm looking to see what they have there. I'm actually kind of excited about this literary review because of that, because I'm mixing the two things that I like, that is the technology area and the business area.
Yeah, it's really cool. And then, like, since Florida is such a big tourist place, if you look up like the Disney hotels, I'm sure they get lots of,
and they're doing
so
many things related to IoT. So yeah.
And then a lot of hotels do like those rewards, like the Hilton rewards, and it makes their customers come back even more once like they sign up. So yeah, you definitely have a good topic. I like it.
Yeah, thank you. Yeah, it's really cool to see, like when I was reading, they had like on the phone, I don't know if you already went to a hotel that has the key is actually on your phone. So you don't have, I mean, if you don't want anyone to go and clean your room just for like privacy, you don't have to give them access to the hotel to go and clean your room. It's up to you. If you choose not to let them do it, the door won't open for them. So it's a privacy thing, which is a really cool feature. Plus, I mean, you have your phone all the time, so you don't have to have the extra key and then the phone. So it makes it very, very, I guess, safe in this case, since that's what they're kind of like looking to do with that. Plus, obviously, I mean, I'll go over some of the other things that they're doing. They're very exciting.
and I have a question.
Sure.
So I saw that in your presentation, you already touched on some of the complications that kind of faces with respect to being applied in hospitality, like software complexity, security, and other things. What do you think is the largest, I guess, barrier that engineers have to face looking to integrate IoT further with hospitality?
From the engineering point of view, I would think is the fast-paced data generation, just because all this, I mean, this technology, or not this technology, this market, the IoT market in general, and big data, they're growing exponentially. So at what point is the engineer going to be able to handle all the data that is passing through all those devices that are connected? So how are we going to be able to deal with that? I think that's going to be something that is not going to have an end, because it's something that every day we're going to have to be improving the program that we wrote yesterday, because the algorithm is not working today anymore, because now I have 10 times the amount of data I had yesterday. So that, in my opinion, that's going to be one of the main issues that we're going to have as engineers. From the business point of view, at the beginning, while they get some handling in the situation for IoT, I think the main issue can be money, just because they have to obviously grab a bunch of money, just put it aside, so they can pretty much invest it at the beginning, because at the beginning, they're not gonna get any money out of this, because they have to implement all the operational stuff. They have to hire people, they have to buy, the computers and all that stuff. And then once they're able to go through all the process, is that they're going to start seeing the benefits that IoT, all the data that they're generating can provide to the business. So those are probably challenges that I'm seeing. Now, from the customer point of view, it could be privacy, because they don't know what type of data the hotel is going to have, and what are they going to do with that data, if they're going to share it with someone else, how are they going to use it. So there are definitely things there that probably some type of regulatory entity, the government or something, is going to come and say, no, things have to be this, and this way. So yeah, there are different challenges there from different points of view. I'll be addressing those also during my literary review.
Okay, thank you.
Thank you. Any other question? No? Okay. I guess we can continue then with the next group. That will be the last group, right?
Yes, that's correct.
Okay, awesome.
Hello? Can everybody hear me? No?
Yeah, we can.
Oh, yeah, I'm sorry. Good afternoon. Our group's number 4. There are 3 of us in our group. We're going to be talking about the electrical vehicle intercommunication. Sorry. So our topic will be basically how the communication within the vehicle interact with different protocols in the system. We broke down the vehicle has many protocols. I mean, not many protocols, some protocols where they can interact with each other to make the vehicle functional and make things to move the way that we want. However, this technology needs some more research into it. to come up with new inventions and how the different properties we can come up to increase that network between these protocols. Some of those protocols that we have, the CAN bus, the LIN bus, the LVDS, the Ethernet, and the ECU. Our objective is to show how electric vehicles works between each other, to also to determine how they can communicate not only within the vehicle, but also with other vehicles at the same time, because that's one of the issues that we had someone in the presentation that was talking about that, how they can communicate with another vehicles so there won't be no car accidents and stuff like that. And of course, we'll be talking about the security issues that within this inner communication has against the vehicle. Someone can hack it and take the vehicle and do things that you don't want to do, you know. Miguel?
Sorry, guys. So yeah, so the problem is that as the future comes by, we want to kind of, like how you guys were talking about the Teslas, we wanted to kind of create a new way for the cars to be able to communicate. And there's different ways for the cars to communicate. We've been seeing things online about like the cars to be able to communicate with the grid, with the electrical grid, which creates like shares the energy that the vehicle has from a charging station and then gives it back to the grid. So it's one of the ideas that we can talk about in our project. Obviously, there's not that many electrical vehicles that communicate with each other. Probably just Teslas that communicate with each other. So that's the whole point of really using the protocol systems that we are going to talk about in the future. And then, of course, as you put things more in the internet online, there's more things like security-wise that are more important. You know, people can hack into the cars, people can hack into the systems, and then things can like kind of fall down into a domino effect there. But yeah, the next slide. Sorry.
All right, hi guys, I'm Ari. The significance of our project is to explain electric vehicle communications. They're vastly changing year after year. They're gonna get big because of renewable energy resources being connected to the grid now. And that is now incorporated into electric vehicles. We're gonna go into a little bit of detail of that, but it's not, we think that knowledge of the electric vehicle is like necessary to everyone, because I've read statistics that like more than 50% of vehicles by 2050 or something like that are going to be electric, or more. I've read more than that as well. It just depends on crazy amounts of information. So we want to explain it in such a way to where the engineering side can be understood, but also a consumer side can be understood as well. Like, it's important to know that information. So I feel like it's a lack of knowledge that we just want to like fill in.
So for the car communication, there's different types of protocols, but one of the biggest ones, which is a standard for all the cars nowadays, even for the ones that are not electrical, is the CAN bus system, which is just, you know, we're talking about like is the biggest ones really even for now. So we're just going to talk about and kind of give the history of it. You know, like the implementation, because it's one of the simplest implementations nowadays. All the cars, really even for industrial cars, use it. And it comes down to also like how I wrote here, ISO layers. It's basically like ways of the link layer and the data layer is how really the ECUs really communicated with each other, which is something that, you know, the professor was, you know, he mentioned and touched, and we've been talking about in class. We also talk about like how, you know, we're also going to talk about like the CAN message, how like the message it's split into different IDs, and how each piece of the communication of the cars actually communicate with each other. So definitely better presentation. But for the next slide, I talk about like why CAN system is so popular. And it's, you know, it's a low cost, it's a very simple, very simple system. That's why it's been used, you know, it's been used for already like 30 years already. The cost, the robust, which meaning that since there's a lot of electrical systems, even when we going to add more electrical systems with the whole electrical vehicles, it repels all the electromagnetic fields that are going around from all the devices. The efficiency of it obviously is going to be a big thing. Even though the cars around nowadays are very efficient, there's going to be a need for more efficiency, especially when you put information out in the internet. And then it's fully centralized, which means that it's just the way that everything communicates. There's a point in the middle that all the information go back and forth. And how I mentioned the messages from before, how it breaks down the messages, that's going to know what is going to be priority, not priority. Next slide.
All right, Mike, part of the presentation is the lean bus. This protocol works together with the CAN bus, as Miguel just explained to you a little bit about how the CAN bus works. The CAN bus, it offers at least data length of 2, 4, and 8 bytes. This protocol supports detention, checksums, and configuration. This protocol supports sleep mode, wake up mode, which helps to lower the cost at the same time, not to consume a lot of energy. This lean protocol was released in 1999 by a group of automobile groups by BMW, VW, Audi, Volvo, and Mercedes-Benz. The reason behind it build this system that will work along with the CAN bus is to do simple tasks in the vehicle. The lean bus applications include the connection of intelligent actuators or sensors, windows, such as small motors, temperature, rain sensors, sunroof, heating control. These applications, of course, they have the limitation. They're not managed to do certain things. That's why the CAN bus is there for it. For example, as you can see it on the picture, on the left side, when a driver trying to lower the window from the left side to the right side, so of course to do so, you have to press a button. So that button when you press a button, send the signal to the lane, to the other side of the vehicle. But the way to do it, needs the CAN bus. The CAN bus receive the signal and then send it to the lane. The lane, of course, they have blocks of instructions that receive from the other side of the lane. They communicate to each other. Of course, if it's always get confused, a lot of people confuse the lean bus with the CAN bus. However, the lean is it's lower cost. CAN bus use twisted dual shield wires up to 5 volts. The lean bus use single wire to 12 volts. The lean is more cluster, have a single master. The CAN bus uses from 11 to 29 bytes identified versus 6 bytes identified on lean. The CAN bus offers up to 1 megabytes per second versus lean. The protocol offers up to 20 kilobytes per second. There's 6 type of lean frames in the system. However, these systems, the most common one is the number 1, which is the unconditional one. This type of frame is used commonly in the vehicles now these days due to the fact that it doesn't need a lot of data at the same time to send from the headers requesting information back and forward from the specific slave. Note that also the basic link types are here, but each individual one has their own but each individual functions. And like I said, the first one, the conditional one, is the first one that most vehicles use. The feature of this technology, the lean, The link protocol serve is important in a role. It's low cost and the feature spending modern vehicles. Link has exploded from popularity from the last decade from 700 million nodes expected to the industry by 2020 versus 200 millions in 2010. However, the rise with lane also comes increase of security, cybersecurity. The lane buses face similar risk exposure as CAN bus, since lost lane bus can play a big role in how to adjust your seat, the steering wheel, and all of the sensors in the vehicle.
All right. I'm just going to take a break real quick. We basically researched a lot of this and our heads exploded. There is either a wealth of information or a debt of information because companies like Tesla or they're trying to keep their technology like under wraps, understandably so. So there's a lot of research. There's a lot of things to try to uncover. So we're just going to kind of go over general communication stuff. Anyway. I'm just going to go real quick. One of them is low voltage differential signaling. We wanted to mention that it's used interchangeably with Ethernet, which I'll talk about next. It's way faster than Ethernet though, but the problem is it only sends one bit at a time. So this is used in cameras, displays, and infotainment within the vehicle. Next slide is the Ethernet. It does onboard diagnostics, automated driving, infotainment as well. It's kind of competing with LVDS, like they're trying to develop different ways the Ethernet communicates and replace harnesses with smaller Ethernet. Like Ethernet cable is actually heavier, but if they design it in such a way where it's going to be less wire, they're trying to seek out that as a potential replacement for like LVDS. All right, and my last topic is the electronic control units. So these are basically all over the car. There is, I think, like per car, there's at least 50, if not 100, depending on the vehicle. This is just a small example of one, like the vehicle controller is an electronic control unit that connects to the CAN bus. Then there are other electronic control units like parts in the drive motor, the power management system, instrument cluster that connect to the CAN bus. And these are basically like one chip microcontrollers that send and receive data. And we're just gonna go over like how that works. There's several different ways that they send information. So we're just gonna try and cover how that's done. I'll probably select like quite a few ECUs and then just go from there. All right, so our project schedule, first 2 weeks, we're gonna do research. There's a lot to do. I'm sure you guys who are in automation have already discovered a ton as well. And then the next July 12th week, we're gonna do paper and presentation draft. The 19th, we'll do final modifications. 26th, we're gonna finalize and practice our presentations. And then of course, presentation week. We wrote down what we're responsible for. I'm doing ECUs, LVDS, and Ethernet. Alex Torres is doing LIN and Miguel Ortiz doing CAN bus. All right, so anyway, our conclusion is that we're going to do a literature review on automotive communication networks, their protocols, security measures, and future technology, such in a way that bring knowledge to further the understanding of electric vehicles. Because like I said before, there's like a lack of knowledge there. So yeah, that concludes our presentation. Any questions? Is there references?
What's your motivation, each of you, for this topic? Are you just really interested in electric cars and the operations of them? Because I find that this topic really interesting and just how things work.
Yeah, I basically just like have always liked the idea, and then I was like, I don't really know how these things work. Like I've worked on standard internal combustion cars. how do electric cars work? And I was like, you know what? We're doing a communications class. Why don't I research that? So that's kind of how it came about. Like, I didn't know, so I want to know. And so that's what we're going to do.
But for me,
Also,
to be
just I
honest,
just
like, oh, go, sorry.
oh, go ahead, man.
No, for me, like I just like I always like love cars too, but I'm more like it's not like about the car situation, but more just the communication situation. Like I would like to just create like grow my own plants, and I wanted to build my own system that can communicate with each other, even create an app or something that I can like get the weather, get like precipitation, everything like that. And this is even though we're talking about the car, it's talking about like Internet of Things and like kind of how to get data from other places. That's for me.
For my part, I always been fascinated how the Tesla vehicle works. They talk to each other, but I never got into the details how they communicate. So this research has helped me a lot to understand the basic concept, how vehicles communication works inside the vehicle, but also how we can further the technology in the future, how we can help. So these vehicles, not only from Tesla, but from Toyota and BMW, to be able to all of them to have that communication to each other for vehicles to be right on the road without the need of us, to be crashing anything. So they can at least, communicate. There's a car, it's a broke down car, about 5 meters or 10 meters. So at least they had that alert, like a 20 meters down the road, there's a vehicle broke down. So they start changing lanes, or taking another precaution. And I always love that. So that's for my end, for me.
Like I also think like the whole vehicle to grid subject is like very important, because there's so many cars that are out there. And like I watched a video saying that there's so much energy that we're not really using it with our vehicles. We drive our cars probably like 30% of the day, and then from there, like our vehicles are just parked there. So I feel like even as vehicles, because I know there's going to be like a whole movement of electric vehicles in the future, probably 10 years from now, and all that, like that's a lot of power that we can just kind of renew and just recycle all along. With most of, there's a lot more things going on, but I feel like that's one big step that we can do.
Also, to add on, I watched a video not too long ago, how, in the future, of course, that would be, years down the road, you purchase a vehicle, right? And then let's say you don't do anything for the whole week. Let's say you're staying at home and you got sick. You can, you can actually set up in the app and make money. Your vehicle will be driving by itself, delivering or taking passengers or doing whatever you got to do, and go and charge himself into electrical grid, and then tell them, hey, come back here, come back on, I gotta go home or gotta do something. And the vehicle itself will come back. So all that communication is very, very critical when it comes down to all those little details in the future. Any other questions?
I also want to ask if you were going to go over how Teslas talk to each other, or at least how some electrical vehicles talk to each other, because I find that really interesting. I didn't know that Teslas did that.
Yes, how the basic concept, how they talk. Tesla company is the only company in the world, the automotive company in the world that have these enormous data where these vehicles, you driving the vehicle down a road, and these vehicles are learning at the same time you're driving it down a road. So these vehicles are learning and gathering all the data around them. So that data gets shared into the cloud of Tesla. So what's going to happen down 20, 30, 40 years down the road? If you want to build a vehicle who wants to drive by himself, you're going to need all the data available there. You're not going to start from the bottom. So what Tesla is going to use of data and sell it, I have this data that you can use it and plug it in your vehicle, the Toyota, whatever, and your vehicle will be fine, of course. But it's amazing how the Tesla vehicles, they learn and they actually send the data into the little Tesla cloud, and that's how they, they get better. There's something that happened to this vehicle, got a crash. Of course, we have seen it in a lot of across the United States. So of course, they study what happened, what we can do to improve it, so this doesn't happen again. So of course, down the road, these vehicles will be, fascinating.
I had one quick question. Alex, I think you're doing Lynn, right? On your focus areas, I think you were doing Lynn.
Yes, Lynn. Lynn is basically it's it works along with the Canvas. So if you want to, let's say when trying to lower the window on the right side, you send the signal from your door, so it lowers the window, and it connects through the Canvas in order to lower the window on the other side of the vehicle.
I saw in that picture that you had like all the frameworks. Are you covering all of those, or was that just for this?
I only covered one, which is the one that is commonly used. I try to cover all of them, but I will cover those.
It might be a lot.
Yeah, it might be a lot, and I was like, oh, this is too much. Maybe I would cover 2 or 3 more, maybe the most, depending about the time.
Okay, cool.
Any other questions?
Okay, I guess we need to tell the professor that we're done, right? We're done with all the presentations.
Yes.
Yes.
Okay.
Now, Paola, do we press pause, then stop?
Okay. Yes, so you press pause, stop, and I don't know if both of us are going to get the notification or if it's just the first one that pressed the button. So let's see which one.
Well, no, it still says you're recording, so I stopped mine, and it says it's going to convert into an MP4 file.
Okay, I'll stop it now. Thank you, guys. It was great, but don't go. We have to go and tell the professor first, just in case.
Yeah, he mentioned